ADAS, and I've been managing this trial this year looking at the control of thrips in strawberry using Alyssum companion plants. So we're here today at Busby Partners. This is just north of Birmingham in Tamworth, and this is a commercial everbearer strawberry crop. This crop is grown on tabletops in Spanish tunnels with constant drip feed irrigation. So this trial is all about the control of thrips in strawberry. Thrips are a really significant pest in strawberry, and the biological controls that we currently have available are not necessarily doing the job in terms of controlling all the thrip species we're now seeing in the crop. So this trial is all about using Alyssum, which we have a plant of here. We're using the Alyssum as a companion plant to support the natural enemies that we're releasing to control the thrips. So Alyssum is already used quite widely in continental Europe as a companion plant. We're aware of the use of Alyssum in crops such as alliums, where it's being implanted to aid the control of things like onion thrips. It's also being used commercially in some strawberry crops in continental Europe, but more in the context of supporting hoverflies for aphid control. So in this trial, using the Alyssum to look at the control of thrips and supporting thrips enemies is sort of fairly novel. Thrips are a hugely significant pest of strawberry. The damage is very much a classical bronzing damage. You see this brown netting, blotching damage, and that can cause quite significant losses in the crop, up to 90% in really bad years where it's uncontrolled. The control of thrips currently relies upon sort of two main biological controls. There's the predatory mite, Neoceolus and Cumaris, which controls the larval stages of the thrips, and there's also the predatory bug, Aureus laevigatus, which is able to control all life stages of thrips. Now the use of those two biological controls often means you can control thrips well, but that biological strategy has been developed around western flower thrips, and we're now seeing more significant problems with other thrips in the strawberry crop. I'd like to think of these as sort of hit and run thrips. They move in from the hedges and nearby crops, and they move in as adults and cause the damage as the adult stages, and now that causes problems for the IPM strategy we have, in that we don't see the larval stages in the fruit, and it's those larval stages that some of those predators, particularly the predatory mites, are controlling. So the idea of this trial is very much to try and support the Aureus laevigatus in establishing within the crop and keeping it within the crop between the flushes of the strawberry flowers to try and control these hit and run thrips a bit better. So there are a number of species that I like to think of as these hit and run thrips that are fairly new, causing damage in strawberry. There's rubus thrips, onion thrips, rose thrips and flower thrips. And these tend to, based on sort of previous trials, we're seeing that these species move into the crop as adults and seem to cause the damage in their adult stage very quickly before moving away. And this causes big problems in terms of the current IPM strategy we have. So the idea of using an Alyssum plant as a companion plant is sort of twofold. Firstly, we think it should act as a trap plant. So this is obviously a nice, large, attractive plant. Our hope is that it's drawing the thrips into the crop, serving as a trap plant, meaning that the thrips will hopefully be moving away from the strawberry. The second part of using the Alyssum is also our hope that it will serve as a banker plant. So this is the idea that we're providing a large floral pollen resource for natural enemies, things like Aureus. So this should hopefully allow the Aureus to establish better in the crop and persist between the flushes of the strawberry flower. So it's sort of a two-pronged approach that we've been looking at. So if the Alyssum proves effective in this trial, our hope is that growers will be able to grow the Alyssum within their crop, probably at something like 10 to 15 metre intervals, to provide this floral resource and hopefully act as a trap plant. We're aware of some growers in the UK already who are using the Alyssum, and they've had quite a lot of success also using it as a release point for their Aureus laevigatus. Obviously, manual labour in the strawberry crop is a huge issue, so if you can do something like release your Aureus into the Alyssum instead of having to release it throughout the entire crop, that obviously comes with large savings in terms of cost as well. I think the future is hopefully bright for the use of Alyssum as a companion plant in strawberry. I just wanted to offer my thanks for Busby Partners for hosting this trial. It's been a really interesting trial to work on, and I hope that if the results are positive, this might filter through and have some positive effects upon what strawberry growers around the UK and Europe overall are doing in their strawberry crop to manage their thrips.